We're going to record
No,
this
not.
today. So we're gonna
Well,
be
he's
stopping-
spelled with a G, so we're safe. Sorry.
That's all right. We're going to be stopping about every 20, 25 minutes, something like that, to change the desk and the camera.
Oh, right.
And the idea kind of behind this is use it as a supplement to the training that we do. We're going to send you guys a copy out, and if you get new people on or something like that, they can be able to kind of watch it and be trained on it too. Chances are, by the next time that you guys get vehicles, they will have a different electrical system out. What you've kind of experienced is the phases that we went through to kind of get where we are today. We went from the RC-tronics to what we call the EP1. And the EP1 was basically a hardwired, old-style relay configuration panel. But of course, if you ever work on the back of those, it's just a big spider web of wires. Well, we went to the EP2, which is what you have now in the last 25 Aero Elite Chevys, and they have the printed circuit card in them. The only purpose of that printed circuit card was to get rid of that spider web behind the board. That's it. The wiring is exactly the same going from the EP1 to the EP2. Now the EP3 went one step further because that's actually what we tried to progress in the new technology was it has all the add-on cards on the back of it. So the physical board has screw holes that mount the add-on card onto it, which are probably about 4 inches square. And when it screws on, those screws are each of the circuits that power the board for power and ground and whatever circuits that need to go through. Okay, so there's no cable running from board to board. Now when that's put on there, it's used, they actually use those airplane screws, the ones that when you're putting them in, they kind of crackle as you turn them because they're self-locking into the post that they're in to keep them from vibrating out. But when those cards are put on, they actually have jumpers on the board that allow you to just put a jumper in for whatever is designated on that list. Like if you want the lift door to ajar with the buzzer without the park brake set, you put a jumper in and it'll do that. Okay. So I mean there's tons and tons of different options on those boards, from full court systems to flashers. The buzzer is built into it, the chime's built into it for the full court system. And all kinds of things like that. So that's just to make you aware of what's coming, probably next time you get those buses. The actual implementation of that EP3 version is actually going to be in like 2 weeks at our facility. So anything built after that will have that in there. And that'll be our standard. We're not going to anything else after that. It's the final phase of what we're doing. So to kind of get you to that process, we brought the overall wiring prints that we're going to go over. First, what we're going to do is we're basically going to go through the book. A lot of this is repetitive to what we did last time. So we'll go through here and kind of just go through the basics of the electrical stuff. Once we're beyond that, we'll take a short break, and then we'll go through all the electrical with the overall wiring prints. And after we get through all that, we'll take a short break, and then we'll go out and work on the bus itself and go through the routings and stuff. And there again, the routings are going to be common for what you're used to anyway with the RC-tronics. The original and what we kind of trained on last time too, so it's kind of repetitive also. So let's go ahead and get started with the manual itself. When you open it up, I kind of added a page in here, the very first one that's talking about who we are as a company. That's just some tidbits about Thor and Eldorado and kind of what we try to achieve at the factory itself. And some of that stuff, I know when you get buses, there's always little things that are wrong, or you got little things that go wrong with the vehicles, and that's pretty common no matter what you look at. We try to pride ourselves on having the least amount of errors that many of our competitors, would see. And our quality is far superior than a lot of our competitors when it comes to the market we're in. A lot of them don't use the fiberglass molds on the inside with the liners and stuff that we do. They do not use the fiberglass body walls that we do. The advantage of all that stuff is the flexibility. When you're driving, if you ever look at the buses from the back, you'll see that they actually twist, when you're going across bumps. The bad part is, a lot of your stanchion screws and things like that will actually physically fall out. We've got some, you guys changed the rivets, I think, stainless steel rivets in your stanchions. Is that right?
I don't know.
I think I sent the part number down for that the last time after training. For stainless steel rivets that other customers have used to hold those in place, because the screws typically don't last. Through the flex of that body, it also helps, with impacts. There's a lot of times, you can have certain impacts on the vehicles, and they may scratch the surface, but they really don't damage the integrity of the vehicle like it would if it was a steel frame vehicle. So there is definitely some reliability with the type of structures they have. The next page, I kind of just threw some pictures on there to let you guys see what the plant looks like. It's got a couple of aerials, and then of course the picture of the front of the plant where the offices are. The next page is actually talking about the actual training course. It says this manual will cover basically the following information: understanding the schematics and the harness prints, the common functions of diodes, relays, and switches, troubleshooting common problems quickly, who to contact, and of course how to get more information. The schematics and harness prints, understanding that's probably your biggest hurdle from company to company that you have to deal with, because everybody has their own way of doing it. There probably isn't a best way to do any of it. I mean, what we think may be easy may be very difficult for you to understand, and what we may think is difficult may be the best way that you would need it. But between everybody involved, it's pretty hard to try to find a common way that everyone would enjoy it. We do things different now. We do things, basically we use the overall wiring prints as the core of the electrical, because it's really the one thing you need in a vehicle than a lot of just basically harness prints is what we used to supply in the past. Kind of like the nail board view where it had a line, and then it had all the wires that was in the connector, and then another line, and it gave those dimensions. Well, those have their benefits because that dimension basically tells you if you know where any one of those drops are in the vehicle, you can always find the rest of the drops based off those dimensions. Well, later in the book, you'll see that we put in all the routings for the harnesses and all the connector locations, so you'll be able to find them without having to use a print like that. So all the new prints we've done in our program software, which is called EP2 Training, it basically is an electrical software that allows you to wire kind of like on a test board in the software itself. So when you wire from point A to point B, it won't let you cross-connect a wire to another wire. So therefore, it reduces the mistakes in the harnesses themselves. And then, of course, our harness vendor, he was actually supposed to be out here with us. I was going to have him do a part on the harness itself, but something came up and he wasn't able to make it. But he was going to basically kind of cover how they build the harnesses and test them and things like that. Our company requires that all harnesses built by any source manufacturer, they are to be 100% electrically and continuity tested. Okay, that still won't mean that you won't find mistakes, because you will. Because basically, when we get a harness and we say we move buses around in our schedule, because we have a very large backlog, and confirmed orders that come in, basically we get an order, we go through it, process it, we give it back to the dealer. The dealer has to get with the customer. Customer has to approve or give us answers for anything. Has to come back to the plant, go through our approval system, then it has to be processed, sent back out, and they have to approve the final work orders, what we call our dealer acknowledgement. And once that's approved, then that turnaround is actually built. Well, sometimes when those are waiting to be approved, we have to move other units up into their position that they would normally have. When that happens, those units are what we call, the parts end up having to be expedited, because now we don't have the stock to be able to build those units that were moved up. We have the parts to build the one that's waiting on acknowledgement. Okay? So sometimes when those harnesses and stuff are moved up, they're not tested when they're expedited. Okay? So we may need, 5 harnesses, in 2 days, when normally our lead time is 2 weeks. When that happens, that batch of harnesses normally are not tested. So you may find a mistake, to troubleshoot. How did this get miswired, if they're 100%, electrically and continuity tested? Well, that would be why. Okay? So just kind of making you aware that those things do happen. And they don't happen that often, but they do happen. Okay? Now, through that process, where we require those harnesses to be tested, we also have process on how they need to be repaired. Now, when we say repaired, that's also how it's built. We build with splices, okay, in the harness. And we did that a long, long time ago, but we quit doing it because we had our harness shop in-house, and by building them in-house, it made it very difficult to get a good, solid connection. So it'd be driving down the road and wires may come out on a splice or something. Well, you can't get to it without taking all the interior liners out. Okay, and that's like a 4-hour job just to do that. Okay, so now we go through everything. Since it's all purchased, we now go back to inline splices, but they all have to have 2 forms of protection on them. You have to have the steel sleeve or butt connector, uninsulated butt connector, to crimp the wires. Then you have to solder it, and then you have to use a mastic heat shrink on top of it. The purpose of the mastic heat shrink is to keep it from pulling apart through vibration and body twist and all of that. So it's very important that the mastic heat shrink is on there. Now what we asked is that if you repair the wires, okay, the soldering's not as critical as it would be to mastic heat shrink. So if you do any kind of a repair, no matter what it is, it's really good to use a mastic heat shrink on top of it, simply because that glue will keep that wire from pulling back out. Okay. Now we used to use insulated butt connectors on a lot of our connections, and I don't know if your original buses had those on there or not. But since then, the company kind of outlawed those along with bullet connectors. And the purpose of getting rid of those was because we couldn't guarantee a good crimp on them from our production guys. Okay? They have timelines they have to meet to build these units through these processes. And it's not like your bigger plants where this guy just puts in 4 screws and this guy puts, these 2 screws in this one bracket. Our process moves a little slower than that. So through that, you may have this guy's doing all this wiring for this one, and it's really a lot of work for him on this vehicle, but the next one he does like a quarter of the work. The next one is the same amount as that, and then the next one's another hard one. So through that process, he doesn't meet his time flow of, say, 15 minutes per bus. He will take 30 minutes for this bus, 5 for this one, 5 for this one, 30 for this one. So through that, he's got to work around everybody else in that same process. Okay, so it becomes difficult for him to be able to take the time that it needs to do it really the right way. And I'm trying not to make excuses for this. I just want you to understand why things happen. So by using butt connectors, they wouldn't necessarily crimp them down all the way. It would make it through line. It would get out to you. You put it on the road. 3 days later, something funny would happen. You go in there looking, the wire would be on the butt connector. That shouldn't happen. I mean, butt connectors are good connectors. They really are, if they're crimped properly. But since we couldn't guarantee a good crimp on those, then we got away from them. Now we use quick slides. Now the catch is the quick slides are just as bad as a butt connector if you don't get a good crimp. But there's advantages to the quick slide. If you take a light off and it's got butt connectors on it, you have to cut those butt connectors off to replace that light. You do that 5 times and now your wire is too short to even connect to anymore. Okay? The thing about a quick slide is you can unhook it. Your wire never changes length. You put a new light in, it's always the same. You still have the performance problem where if it's not crimped properly, but the advantage to a quick slide is it takes less pressure to crimp a quick slide than it does a butt connector because of the material thickness that's physically in the ring itself. Okay? Now, if you do end up with cases where you have 2 wires going into one butt connector, like we typically use the females as our 10-12 gauge. Now, those are the big yellow ones, and those are a little harder to crimp. And you will have cases, where you see those things and you're looking for a problem that's not consistent, It may be the case where maybe one of those has a loose wire in it. Check those circuits, take a tug on those wires and, make sure they don't pull out. Okay.
Why don't they use those shrink butt connectors?
Well, see, we use those on our van line, and we do use those in some cases on the buses. We use them on the vans because we have no room to put connectors physically between the liners, between the metal and the interior fabric. So it's a room issue. And since we can't use regular butt connectors the right way, then they use the shrinkable ones, which definitely are a lot better. But on the bus side, the only reason is because when you cut them off, they end up being too short after you replace them a few times. Now, in some cases, that probably wouldn't be a problem because you should never have to cut those wires to replace anything. But in our process, we can't guarantee that this is done this way and this way and this way. It's all relying on prints, and then sometimes when a work order says they want something done this way, we don't release engineering documentation for it. Therefore, you don't have a print to troubleshoot it, and production pretty much just goes in there and does it the best way that they think it should. Well, then you may end up with an issue with whatever application they use. But yeah, now you can use those. I mean, as far as a repair, they are an approved repair item. The only thing we can't use in our factory itself is the bullet connectors, and we don't want anyone using bullet connectors. A lot of the lights comes from light manufacturers, come with bullets on them, and we don't approve those at all. I mean, they are a real big fire hazard. The troubleshooting for the boards and those and all that, there again, I recommend using the overall wiring prints for, and then of course keeping a hold of your manual because it has the connector locations in the back of it, tells you where they are. So if that print right there tells you you're looking for C204, this print's going to tell you where 204 is.
What is the
slide? What's a quick slide?
Quick slide is the male and female quarter-inch spade terminal
Oh.
that have the insulation on them, and you just push them together. That's what we reference as a quick slide. I think they're called push
What's
slides.
actually a bullet one? I've never seen it.
A bullet?
Yeah, is that the...
That's a,
The
they're
round
just the little bitty round ones. If
Okay.
you don't get them pushed in all the way, they'll come out, but they won't completely fall apart. They just sit there and arc. Yeah. And that's why they're kind of risky. But yeah, any of those round connectors that have the, I mean, if you look at them, the male side basically looks like a bullet. The female side is just a sleeve.
And you said that the shrink butt, what is it, shrink butt?
It's basically an insulated butt connector, but the outer casing is longer than the butt connector. By
The
about a
weatherproof
quarter
one?
inch.
Oh, the weather, yeah.
Yeah,
Oh, I
exactly.
should just use all those. You know, like these buses, you pull that board, it just looks terrible. Like everything's about to pop off.
Yeah, exactly. So yeah, that's definitely a good one to use if you want to. Eldorado does documentation in 3 different formats. 2 of those formats we'll basically go through in this manual. The third will be shown, but it's a new process, and this is it. This is the third process right here. It's actually our E3. Last time I was up here, I didn't have those with me. We had just started developing the templates for those. We sent those up later. I don't know if you guys had a chance to actually see those or not, but they are available for the RC Tronics units. That's the ones with the printed circuit card that has like 20 relays all across the middle and all the ring terminals around the outside. On the next page, it goes into some detail about the different harness brands. You got the overview, which is the older traditional. You won't see too many of those in your vehicles, but you may end up with a few of those prints just for the fact that if they call out something we haven't built in the last 2 years on your bus, then that's the print that's going to be associated with it. The schematic and harness separate, which basically is a format we started using with AutoCAD. It's actually some of these, when you look through the print, you'll see the black pictures. That's how we draw those in AutoCAD. And this one here, of course, is the last one, which is the E3. Turn to the next page. Basically, it's getting into detail about the codes and the labels. The codes and the labels on the prints. These are for the older style ones. And as you start flipping through here, we're just going to run through these real quick. It kind of tells you the first item in the line is the bill of material item. This tells you what part you need to use to replace it, or something similar. You don't have to use the exact same part. Like I said, if you're looking and you see butt connector, I'd rather you use the weather ones than the regular ones, or you could use the quick slides. You run across where it tells you what terminal to use in connector housing. You need to use those, or if it's in an application where you feel it needs to be different, like for example, let's say it's got a connector on there, but it's next to the floor where there's a sealed hole. Let's say you're having a problem with that seal staying there and you want to use a weatherproof connector of some sort there, then you can use the Weather Pack series or whatever you use for a sealed connector, Deutscher. But then, of course, you got to replace all sides of the connector, not just part of it. The next item on there at the bottom talks about the 06. That's the circuit number. Every wire in the harness actually is stamped with a circuit number. It also has the function on it, and the circuit function is actually done with an inkjet printer. Where before, on the older harnesses, if you ever had any of those, they were actually done with a hot stamping. Well, when you would pull the panel down and you'd be in there working around and troubleshooting and testing, you come out, your arms would be all black because all that hot stamping came off on your arms when you were in there sweating or whatever. Okay, so the inkjet will not rub off. It's a good stamping. There will be cases where wires will not be stamped. Okay, those ones are run custom by our plant, not purchased in-house. Okay, the process for that is typically to, when you troubleshoot it, to take the circuits that are stamped, because no complete circuit will be unstamped at all. Okay, if you have a wire running from point A to point B and it's using it for a special system, now this is not standard options we do, because all the standard options, everything, all that's stamped. But if you call out for something custom, and that custom circuit actually has a relay put in it with a wire going from that relay to its tie-in point, which may be up to 2 feet long, won't have a stamping on it. That's what I mean by it. But the output on it that the circuit's being used will be stamped. Okay? Our colors for the wires are common, so you know green is always ground. Now there is one case where a green wire is not ground, and that's on a radio circuit. And the only reason that one's not is because we match the national standard for wire colors when it comes from a radio. Now you guys don't have a radio in your vehicles, but you still have the wires there for one if you ever put one in. So if you got some kind of a enunciation system that uses speakers, you can tie right into that harness and all the speaker wires at that point. And I'm not sure how your poor little guys are hooking all that up, but that's there. It could be used for that. The wires are also stamped with color. So in here, a couple pages down, you'll see one that says color codes on the bottom. Those are very important to keep a hold of, and I added them to this sheet right here too, on the bottom of the overall wiring print. It has all the color codes, and it also has a standard legend. It doesn't have everything on here, but it just has more common ones, what a fuse looks like, what a diode looks like, that kind of stuff. The older prints have shortcuts on them that tells you LT is lights, WC is wheelchair. Well, that was back with the hot stamping. You were limited to 13 characters because it used these metal dies for like the typewriter ends, and they all inserted in the deal. And then, of course, it stamped the wire with a stamp pad. Well, the new DeskJet printers, you know, you can write a full book on there. You're unlimited. You can write 80,000 pages, you know, front to back across a piece of wire. So now we write everything out. So instead of saying WC, we write wheelchair. Okay, pull cord. Instead of being PC, it's written out pull cord. So that makes it a little bit easier when you're troubleshooting. But the wire colors are all still shortcutted. Okay, and the reason that is because on our prints, if we try to write all our wire colors out, it becomes so cluttered that it makes it difficult to try to trace your circuits. Okay.
How do you come up with these terms?
They were there a long time ago. I know, it's, you know, purple's always been B for everything I've always looked at. Now, I'm used to this because, of course, I've done it for, you know, looked at it for 11 years, but it's, yeah, it's the wire colors, and the hardest thing to do is to change things, because when you change things, you know, everybody that's had buses for the last 10 years gets really confused because, you know, you change one wire color, so we've never changed it. But yeah, it's been there for quite some time. On the next page, you'll actually see, after the wire coloring one, you'll see this is actually an E3 print. This is the one we were talking about in the new software, just like these overall wiring prints. And you'll see it's a little bit more realistic for a schematic. It shows you the terminal, it shows the connector housing it's in, and all that's on here is everything that has to do with this print. Now there's some cases where you may look at a schematic for the exterior lighting, and it's pretty overwhelming because we have a lot of exterior wires or exterior lighting wires in the vehicle, even though you may only be using half of them. The harness is set up as a standard. The harnesses in this vehicle are the exact same harnesses we use on a 19-foot Ford and a 19-foot Chevy, you know, the little GMT chassis, 610 chassis. I mean, they're just standard on everything we do. So you have a lot of drops in there that maybe there's a rear drop for a tie-in point for a Ford that you would never use on this Aerolee Chevy, where your tie-ins are all right behind the driver and that wing pad that go through the floor. Okay, but they're universal. And that also allows you to use a lot of spare wires, because out of that whole bus, all your options are in there. So if you go troubleshooting how come a circuit's not working, and you find out that the circuit is bad from point A to point B, you don't have to fix it. Okay, you can just bypass it with another wire. You have, in that bus, you probably have 7 spare wires running on the overhead. So all you got to do is take a wire, dependent out of one, pin it into the one where the spot was the wire was bad, go to the front, do the same thing, and then it should work. Of course, then you have to keep track of what wire you're using now as the stamping on it, where you may have been using, you know, 23 pink. Now you're going to use, you know, 03 tan. Okay. But it saves you a lot of trouble from having to physically take all those interior liners out to trying to find where this one wire, you know, had failed. Because sometimes, you know, we run across wires where physically the wire looks intact, but the copper inside is broken. You know, and a lot of that may have to do with the companies who manufacture that wire when they go splicing that copper together internally, I mean, you can't see those points, but they may not have a good point where they were welded together inside of it, and they may break. They may even have a gap in them when you get them. Now, hopefully, we would catch that stuff before you got it, but if it's close enough to make a connection and then it gets out vibrating on the road, I mean, electrically, anything can happen. Of course, you have to remember, too, that, 90% of all electrical failures, are grounds. I mean, whether they need cleaned, we do grounds on the outside of the vehicle. Your vehicles on the rear AC are either grounded to the rear seat track inside on the driver's side, or they're grounded to the frame rail underneath. They're probably going to the seat track on the inside. I don't like using that spot because that, according to our company, is a redundant ground position, not a primary. So you should not have any primary grounds there, but that is the primary AC ground. Okay? So, and the reason I don't like it is because it's hard to get to, especially if you got seats there. You got to take a seat out just to get to that ground. Okay? Now, if you got a fold seat or a flip seat or something like that, it's a little bit easier to get to. But on a regular seat that doesn't fold down or anything, it would be a lot more difficult. The nice thing is it won't corrode being inside like it would be on the exterior of the vehicle. The only one you should have to worry about is you're going to have a ground strap going from the floor steel to the frame rail. Actually, on a Aeroleaf Chevy, you might have two, one in the front by the driver and then one in the rear. The battery is grounded direct to the frame. Those chassis use a direct ground process. Instead of running the chassis to the battery, it runs it to the frame rail. So your entire frame rail is ground. The next print in here you're going to have is the ignition tie-in point. This is the actual wire that powered. Now this is the same whether it's an RC Tronics or a regular, okay, or the EP2 that you have out there now. This ground point is in the radio hole in the dash. Okay, it's fused by Chevy, and we basically just use that wire to power the 20 purple wire on our side, and that 20 purple is what turns on the Eldorado above the driver electrical center. Okay, if you turn the page, you'll see a picture of it. This is probably the one thing that'll give you the most trouble through the life of the vehicle, because it's dependent on so many things. If Chevy circuit blows, this wire will be dead and you'll be trying to figure out why. Okay? But it is fused on Chevy's side. The next page is actually where we get into just showing you some routing prints. It shows you how the harnesses run.
Is that 20 purple the same hooked into the cigarette lighter?
No, it's a radio power wire. It's right off the radio connector. Now some of the older ones, they may have done that. Finally, in the last, you can go ahead and change that if you want. I'll just keep talking. I'll talk about stuff that don't really need to go on there.
Okay.
So that's a lot of times how you get back feeds through there. Is you got two wires, somewhere in the back, they melted together, they're shorted, and something else on the board starts doing funny stuff. And then that's when you're just using those spare wires. You'll just take that one out, put another one in, go to the back, do the same thing with the same wire, and away you go. Okay. All the wires on the board are silk screened on the board. Okay, so when you look at the back of that board, it's going to say 20P and 23I and 7G and all of that. I mean, they're all stamped on the board. So if you're troubleshooting off this print using a 20P, you can go right on the back of that board and just look. Oh, there's 20P. Unplug it, test both sides up to make sure you got power coming from the chassis, make sure there's no power on it on the board. If there is on the board, your board's bad. It's that easy. Okay? You don't end up with other circuits going through the board the way the board's wired that would create a problem like that. One circuit is not going to go through the board and cause another circuit to work. Okay, because all the circuits coming out of that board are either power or ground, and they're all individually relayed. Okay, and they're triggers. So if you got triggers coming in, it's triggering one relay, it's not going to trigger another. And it sure ain't going to be on your output of it, okay? So it makes it very easy to troubleshoot if you can determine whether it's in the harness or in the board, okay? Auxiliary fuses on the top row, on the far left side, you're going to have 3 fuses missing. The far 3 left ones, you're going to have 2 fuses in it, and then you're going to be missing 2 more fuses. Those are all spares for whatever you want to use them for. Your guys put in orbital systems. You guys may want a different circuit for adding in, say, the bypass for the interlock. Go into a battery circuit. You go right up in there and you go into that fuse. Now that doesn't mean your fuses aren't already used, because if you call out custom things going through a production line, they're going to use those spare fuses. So when you get the bus, you may not have any. Well, that's okay, because all of those fuses are no load. Okay? It's like you don't have a radio. Well, there is a radio fuse up there, so you can use that fuse for whatever you want. There again, pull the fuse out. If the red light comes on, you need that one. Put the fuse back in. Go to the next one. If the fuse is off, use that one for whatever you want. Use that for your interlock bypass fuse. Okay? That way you're not putting multiple wires on one fuse. The decals on the front, you could also, mark those things out and rewrite what you use it for or something like that too. The diodes on the board are 6 amps. Okay. We do them as 6 amps because we want it to be robust. We don't want to burn it out every time. Like I said before, you accidentally bump into it with a piece of metal or something like that with a wrench or screwdriver or something. The next page shows you physically how it's mounted in the bus. Next page is actually the troubleshooting. We kind of covered all that already. There again, to determine if the problem is the board or the harness, just disconnect the problem wire from the panel and see if it operates normally. Either be a 12-volt power or a ground signal. Everything is 12 volts. We don't use any kind of modifiers to lower voltage. Testing can be done with the panels live, but always keep safety factors in mind. The nice thing about that door is it's got cross pieces in it for the support on the door, where you can take your screws and lay them in there, and when you lay your board down, you don't have to worry about it hitting anything. It's kind of nice keeping track of all that too. I should have 2 foot of extra cable, allow them to access all the internal stuff. All right, let's go ahead and stop right there and let you guys take a 10-minute break. I know I buy from us to begin with and ship it over there, but that's fine. It's because when you try to buy it, from somebody in the States, and they got all these lead times going out overseas, they're going to charge you a lot to expedite it in the middle of that process. So, but yeah, it just needs to be GXL, and as long as, or better. I mean, it can be better than GXL too. We use GXL because of its thick coating on the wire itself to help make it more fire retardant. That's why a lot of times when you look at a connector and the wires are brown or black on the end at the terminal, from it being arcing and stuff, that's because the coating on the wire is protecting it from physically burning. So it just basically slow cooks.
We got double the wire out here for a while. Really hard to get.
Yeah, that's the stranding. Yeah, it's those wires. The better the wire is, the more stiff it is, because see, like if you try to use GXL for a battery cable, it'd take 4 guys to bend it to get it around where you wanted it to, especially if it was 4-aught cable, because it's almost solid. So we use welding cable as our 4-aught cable, which does not meet SAE standards, but that's not. I mean, they don't require it for that size of cable because it would be more of a risk to use a GXL cable in that application than it would be to use something flexible. So, all of our manufacturers have approved, Ford and all those guys. They do it themselves. So, anything you see of 1-aught or above is typically a high strand, cable. Ready? Are you recording? Did you record all that?
Mm-hmm.
Gotta cut all that out. Not admit that. No, anyway. The cables themselves, all route, showing the connector locations. If you flip the next page, this is the adapter harness. All your vehicles have an adapter harness depending on the lighting for the OEM. I don't want to say toe plug because that's not really what it is. It's an OEM trailer wiring connector. Okay, and what that does is that allows them to give us wiring tie-in points so we don't have to cut their wires to pick up exterior lighting. Okay, on your chassis, the nice thing is it's all in one connector, but you're going to have this C215 chassis tie-in connector is going to be behind the electrical center, a little off to the left where it runs down the pillar. Okay, so if you want to look at that wire, you physically have to lay the electrical center down, reach behind there, and pull that over to be able to troubleshoot that. Okay, now some of those vehicles have a pad that runs down that corner instead of a fiberglass piece, and you can just take that pad loose and get to it. But that adapter will run from there all the way down underneath the vehicle, across the frame rail, because the connector is actually on the passenger frame rail behind the entry door. Okay? So this adapter harness right here will run from that connector up to, from Chevy's connector up to ours. Okay?
So the GM wiring is on the frame rail behind the entry door, is that what you're saying?
Yes. Passenger
And
frame
then you
rail.
run a harness
All the way across and up the driver pillar. You know, the driver's seat, there's this wing pad right behind the corner.
Yep.
We go through the floor there, and then it goes across to the frame rail to the other side to pick it up. So if you try to troubleshoot that, that's where it's going to be. And we don't want to wad all that harnessing up, so we don't leave it on the harness. That's why we put this adapter in.
Can you see it underneath?
Yeah.
Top of the transmission?
It's a weather pack connector.
Okay.
Yeah. It's actually a 10-pin connector. Okay, on the next page it has other tie-in points. Now these are new stuff I've added in from your old books. So if you have the old EP2 books from the last training session, you can throw those away. Because this has everything in there that one does, plus I added all this tie-in information. Okay? So on this page here basically shows you how we do an engine kill, a starter disable, transmission park detect, and a park brake detect. And on your vehicles you have the starter kill one, which is the starter disable. You have the transmission park detect, and you have the park brake detect. So it looks like the only thing you do not have is the engine kill.
Why not?
Won't they have
We've
that
got
on
the 8
those?
liter, we've got the gasoline engine in ours.
On the 7000, they're tapped in there under the engine fusing, the gray wire.
Yeah, that's what I'm showing as the starter disable. Does it physically? Oh, you're talking about the fuel door though. You got a fuel door?
No, under the relay center and the engine department, they're tapped into the fuel pump. And that's for the gas door, is that for?
See, I'm showing that's the starter kill. It's a gray 18 gauge at the fuel pump relay.
Okay, that could be.
Maybe Paul. Maybe that's actually should have been the engine kill and Paul put starter kill in the print. That's very possible. But we do two different things. We either shut the engine down and or we kill the starter where you can't start the vehicle. So now if you have you guys have any kind of a fire suppression system on the vehicles?
No. Not that I know of.
Do you have a fuel door
Yes.
They do have.
shutdown?
Yeah, the
Okay,
fuel
then you
door.
have the engine kill if you have a fuel door shutdown.
Okay.
Uh,
Yeah.
7000s, I think it's a starter lockout on that, isn't it? On the RC Tronics models.
Yeah.
But I know we have the engine kill too. We had that one where it was intermittently stalling, running rough, and ended up being, they bypassed that engine kill.
Gotcha.
That's all.
Yeah, so that's what you have then. You have the engine kill. Okay, on the next page here we have the switch relocation for the particulate filter. You guys, you're all A1s, right? Okay, so you won't have that. On the next page you have the stamping codes. There again, this is only for older prints. All the newer ones all have the stuff written out. So hopefully you won't have to use that very often, but it is there if you do need it.
Wire actually says the air conditioner on it.
Yeah. Or to say like, well, like air conditioner, it probably just says AC because that's a pretty common term for air conditioning. Stuff like that we didn't change. I mean, we tried to just change shortcuts like LT. You know, we actually put light. You know, things like that. Sometimes we use, instead of saying wheelchair, because it's such a long word, sometimes it doesn't fit in the areas we're trying to put it on the print, so we'll use the word ADA instead, something common. On the next pages, you can kind of just flip through those. Those are basically stuff we talked about last time where we were troubleshooting relays, showing you how they function. And now one important thing though we will cover, and we did this last time, but our relays are not resistant or have diodes in them. All right, they're just standard old 40 amp automotive relays. Most cases you can use a 20, 30 amp relay. Okay, you don't have to use a 40. Whatever you got in stock, as long as it fits in the pattern and it's over 20 amps or over, you're okay. All right, I wouldn't use anything less than that because chances are most of those circuits are only using 500 milliamps. I mean, or maybe even an amp, and it would never even need a 20 amp. But we like to be safe for whatever reason, and we can't tell exactly what people use those circuits for. So if you always use a 20 amp or better, no matter what, you're always safe. Okay. The relays themselves, on some manufacturers' items, they have your resistors and your diodes across the center. Where this would be your common, this would be your 87A, yeah, 87, and then your two sides. Well, these right here don't matter which is which on ours. You can reverse them. It's irrelevant. Okay. These, of course, are important. We use this 87A for a lot of interlocking items because we want something connected when the vehicle's in a normal state, and then when you apply, say, a lift door or an entry door, we want to break that circuit so that it sets the shift lock or something like that. So sometimes you won't even see this one being used, and there's cases where we'll just use the 87 but not the 87A. Very rarely will we use both. Okay. But when you're troubleshooting them, just know that all you got to do is have power and ground on each side. It doesn't matter which is which, and we don't tell our production which is which. We show it on a print, but when you get it, it may be backwards because it doesn't matter, and they won't wire them exactly that way. On the next page is how to test diodes. A lot of this stuff we put in this book is basically because some facilities don't have guys that are familiar with electrical, so I kind of put this stuff in just to help them out. On the next page is the switch part numbers for Carling. These are the part numbers that you need to be able to get replacements for the driver's lights and switches in the dash. On the next page is the wiring on all the switches. This is a universal page just so it kind of helps you if you're working on the dash. You can take this page with you and be able to troubleshoot any of the switch wirings. On the next page, we're actually getting into the electrical center now. This is a picture of what it looks like in the vehicle. Some important things to note is the rear corner or the corners. You'll see a screw in each one. There's 4 of them. There should be 2 foot of extra wire in there. Sometimes when production pulls the harness across, they tie it up a little bit off center. When they do, you end up a little shorter than the 2 foot. The idea is for you to be able to take those screws out while the bus is running, everything is on, take those 4 screws out, lay it on the ABS door, because you can't short out, it's all plastic, lay it on the door and troubleshoot what you need to troubleshoot live. Okay, the panel's robust, you're not going to short anything out unless you direct short. When we tested this board, the very first one, I took the power post and the ground post on there and I direct shorted them. Okay, I couldn't get the traces to melt. Okay, with the direct short. Okay, all it did was burn the bus bar up where it attached to the board. Okay, out of all the vehicles we built, which we started doing these as a standard 2 years ago, so we probably have around 6,000 of these in the field. And out of all of those, we've had 3 failures. Okay, one, the power distribution post, the nut on the back came loose. It arced until it burnt the traces. Okay, around the post. One important thing is when you pull that board down, it's got heat shrink on the back of those nuts. That heat shrink is not only there to keep it from shorting out against something, it's also there to keep those 2 nuts heat shrunk together. So a cap would definitely keep it from shorting out, but a cap is not going to keep that back nut from coming loose off that front nut. Okay? So we asked if there's no heat shrink on there that you put heat shrink on there. If you have to take the heat shrink off, we ask you to put heat shrink back on it. It doesn't have to be mastic, it just needs to be something to keep it from vibrating loose off the other one. Okay? The new EP3 version gets rid of those posts for that reason, and we don't even have them in there anymore. Okay? But for now, they're a firewall post, so they go through the front and they go through the back. It's double nutted on the back, single nutted on the front. Okay. The second one that had failed was the 70 amp relay. You'll see right in the middle, there's a relay with no stampings on it. Okay, that is the primary ignition relay. That's a 70 amp relay, and it's not removable because it takes the full load of the board through it, so it's hard soldered in for that reason. Okay. If it goes bad, it's not working, tap on it with the handle of a screwdriver. Okay, sometimes they stick. Okay, I've noticed some of these relays, when we get them into the plant, we pop the caps off of them and they have rust in them. Well, I don't know how long they've set in the factory for that to happen, especially it's got to be in a wet environment somewhere, you know. But sometimes that rust causes them to stick, so you got to just tap on them and it'll break it loose and it'll start working again. If it fails, the board is covered under warranty for whatever the warranty period. I don't know what the warranties are on any of this stuff, but it's whatever your normal warranties on the vehicle are. But those are covered. If that relay goes bad, they will send you a new board.
That's that relay you're talking about?
Yeah. Well, it'll be the one right to the right of that. This is hard soldered in the board.
It'll be black one.
It'll be the black one, yeah. Black one with no stamping. Okay, the third one that went bad was because the relay itself, the solder on the back side of the board had, evidently it wasn't a good solder, and it cracked and it arced, basically. And it arced until the copper was burning up around it and it no longer made contact. So all the tapping in the world on it wasn't going to make it work any better. But of all the units we built, and only having 3 failures like that is very good. Now, we've made changes because of those 3 failures, not because they were any kind of a potential hazard. It's just because we designed the system to be flawless, and we think we're there. So, I mean, the whole idea is you guys shouldn't have the problems with it. And all the circuits are robust. They're designed, you know, to handle large amperage. They're not like the RC Tronics where you've got this little bitty trace running from point A to point B. You know, like on the RC Tronics, you know, a lot of your traces on there may be like that. All the Eldorado ones put on their board are basically like that in comparison. And the purpose of that is because accidents happen. You know what? You troubleshoot something, you drop a wrench. You know, it happens. You troubleshoot something, you thought that was grounded, it ended up being power. You know, you shouldn't have to change a board because of that. I mean, that's the idea. So we built the traces large enough that it will keep the board from burning out when things like that happen. Okay, now I asked you not to test it by seeing how long it'll go before it burns out, but okay, on this board there is LEDs. They're kind of hard to see in this picture, but right below this fuse on this side is going to be an LED, and then there's going to be one on the right. They actually look white on this board because they were actually powered up when the picture was taken. But they'll be right next to the metal underneath the fuses. Okay, the left one actually says main on, okay? Now that's going to be on all the time that it's hooked to battery, okay? It's okay, it won't run your battery down or nothing because it is an LED. I mean, it'd have to run for like 9 months before it physically does it. But it should be on all the time the battery's hooked up.
Yeah, white?
It's green.
Green?
It's green. The right one says ignition on, and it's a green one also. And that one's on anytime that wire we talked about in the radio plug, which means the chassis key is turned on. Whatever it's on, that light should be on. Now, sometimes these LEDs will burn out, and they will not be on. And it's okay, it will not hurt a thing. It's your choice. It is covered under warranty if you want to have the board changed or not. But it physically does not hurt anything not having that LED on. Nothing runs through it. It's not a requirement. It was just a benefit. Sometimes it's more hassle to have the bus down than it is to replace the board. Okay? All the wires do run through the bottom to that rings. One thing you have to make sure is if you take those nuts off the power and ground, they have so many rings on there that when you're tightening them up, sometimes the ring gets caught in the thread, and it seems like it's tight, you know, it's as far as it's going to go. But if you wrench it a little bit more, it'll keep going. Okay? And if you don't wrench it down a little bit more, you end up with arc in there, and you end up probably burning that battery post out. Or ground post. On the next page, we got some benefits on here. Some of the features of the board itself. We have the simple printed circuit board design. We took all the stuff off there that you don't use. Like the RC Tronics, when you look at that board, it's a little bit overwhelming because it's got so much going on. But you only use 30% of that board for what you have in your vehicle. Okay? The designs of the new electrical system basically is to do just what we talked about. It gives you the basics, and that's all you're working with. When you go to the EP3, it has the add-ons, but they're on the back, and they're each marked with their own board, so you keep them separate, and you're only troubleshooting stuff that you need to be troubleshooting, not anything else. Okay? Has the robust traces and connection points. The connectors are rated at 18 amps. The primary traces are rated at 30 amps. The primary 50 amp, that's that metal fuse in that picture, is the primary 50 amp auto reset circuit breaker. You can change that to a maxi fuse or a manual reset breaker if you want to. It's all your preference. Some people don't like using auto breakers because when you have a problem, it's just going to keep tripping. It doesn't really stop the problem from happening. Okay, it just allows the driver to keep driving. Okay, and the purpose of that, why we use an auto reset circuit breaker, is because a lot of facilities don't have the technician you guys do. So when they have problems, we like to be able to let them get back to the shop, you know, and all that. So your preference, if you want to use a regular maxi fuse, you can. It just needs to be a 50 amp. The primary 70 amp feed ignition controlled relay, that's that black relay with the no stamping on it. There again, that is not replaceable. All the wiring is plug and play using Molex or amp connectors. All your board connectors right now are all going to be Molex Sabre series. Okay, that's exactly what they are. If you get the new boards, the EP3, they'll be mixed. They'll have some Sabre series 10, they'll have some regular amp mate and lock, or the Molex equivalent. The removable relays, all relays can be replaced. Right now, the only relay on that board that's going to take any kind of load is the 70 amp relay. Okay, all the others you're going to draw maybe a half an amp through. 2 of the relays on the board are going to be for the chime. 2 of them are going to be for the pull cord, which basically just make the buzzer sound and the light in the dash. And then I don't know if you guys get the stop request overhead light. If you do, that's triggered by those 2 relays also. You have 1 relay that's marked entry, and that relay is nothing more than the interlock for the entry door, which you guys do not use, I believe, right? You have battery hot entry doors. You open the doors without park. Is that right?
Yeah, does it entrance on?
Yeah, I think that was a modification I sent down to Russell was how to bypass that.
And the blue buses, they got a...
We are modifying them.
Okay.
They modify?
Yeah, so you won't use that entry relay at all, because that's all that does is interlock the... Because what we do when that bypass is taking that wire out of that circuit and putting it in a battery post.
Okay.
So, it's quick and easy.
Yeah, we are doing that.
And another relay on there is for the destination sign, which is that yellow power wire, it's actually the 14 gray wire that's with the 05 yellow wire above the destination sign area. You guys put your orbital equipment up in a front storage up above, and you have access to those wires, that yellow, gray, and green on a three-way connector up there. It's marked destination sign. Well, that one relay does nothing more than convert the park brake signal to that 14 gray, and it converts all the front marker lights. So all the front marker lights are relayed separate than the back marker lights. Okay. Now, at one time, we got away from doing that. We quit doing it because there was times that drivers were driving around with the front marker lights on and the rear ones weren't because an OEM fuse blew. Okay. Well, the problem is trying to run all those lights and all the destination signs and all the switch lights all on that one circuit. You know, it kind of overloads the OEM circuit. So since then, we kind of went back and split it back up for that reason. The LED troubleshooting on the board, the red LED, okay, these are very important for being able to, you can troubleshoot that whole board without ever taking a print in that bus or a multimeter, okay? If you walk in there and you look at the board and you got a red LED on, that means your fuse is blown and you need it, okay? If you reach over to another fuse, or if you have a lot of spares on there, and you pull a fuse out and the red light does not come on, you can use that in the one that blew. The red light means that circuit's in use. If that red light does not come on, it's not being used. It grounds through the component at the end of the circuit. Okay? Now, I have seen some where the fuse will blow because it doesn't have a good connection in the fuse panel itself. In other words, when somebody puts the fuse in at the factory, it doesn't make a good contact between the tabs. You may have to pull the fuse out, take some needle nose and press that sleeve together a little bit that it's sliding into, and then put your fuse back in. Because if it's loose, now you should be able to rock it up and down, that's okay, but if you can rock it left or right, you should tighten it up or it's just going to blow your fuse. Okay, it's not caused from an overload, it was caused from just a loose fuse. Okay, the yellow LED tells you when the relay is operated. Okay, now the new EP3 boards, which chances are, we'll have to have a separate deal on training, but the yellow tells you the relay's operated. Now all the EP3 stuff actually has a green one on there to tell you the output's okay, but these boards don't have that. So just because your yellow LED is on does not mean your relay is working right. Okay? You can still have a bad relay. The yellow just means that the trigger is going through the relay. That means your switch is good, whatever your source is. Okay? So then if you don't have any red ones on, that means your fuses are okay. That means you still have a problem with the relay itself being bad. So the first thing I would check in that case is to take the relay out and put another relay in, just see if it works. It'll save you a lot of headache. Okay? If a circuit still doesn't work and you got to troubleshoot it, take the 4 screws out of the corners, lay the panel down, and then pull the connector out that's marked with whatever wire you're trying to troubleshoot. Okay? If the problem goes away, then you have the feed either coming from the board or from the harness itself. That's when you're going to need to troubleshoot. You're going to need to test which one is active right then, whether it's the harness or the board. If the harness has the signal still on it and it's not supposed to be on it, it's in the harness. Okay? And it's powering up the board.
Pause that if you want.
Pause it now.
He's going to get... Okay.
So true.
So kind of starting the section out right here in the middle is going to be the power center. It's above the driver. Okay? That's the main electrical center. If you'll notice on it, it'll say like J1, J3, J4, J5, J6. Those connectors on the back of the board. And we're going to kind of start right there in the middle and work our way out. You'll see on the very top it says grounds. Those are all those ring terminals that's on the face of that board. And if you want to, if it makes it any easier, flip back over your book to just a picture of the power center, which is on page 24. You remember last time I was here, there's no page numbers on the book? Remember that?
Yeah.
Oh, yeah.
Well, this is page 24. So So you'll see all those green wires going to the connector. That's basically what that is. That's just a central ground point. Some of the circuits, like on the far left, are going to be your primary outputs, which are going to be the fuses all on the top row. C27A, C27B, C, and D. D is going to be all battery circuits. A, B, and C are all ignition. You can tell that by the strip, the line that runs on the right side of the fuses. You'll see A, B, and C all are connected together through one that goes to relay 8. Okay? Relay 8 is the ignition relay that's controlled by 20 purple, which then hooks into the radio hole on the Chevy dash. Okay, does everybody see that?
What's it gonna work?
Over here? See this output wire right here? All of these?
Yeah.
So every one of those are all controlled by that. See your relay 8 controls all of these through this line right here? That's the big black one with no text on it.
Relay 8, right there. That's your ignition relay.
There's your
The
relay
70
8.
amp
See the
relay?
strip controls all of those fuses. What's that?
Is that the 70?
That's the 70 amp, yes.
The big non-replaceable.
The destination, that's the destination relay. That's the
Yes,
one you're
that's the one we were talking about
saying.
before, Kevin.
And it's hard soldered in there.
Well, that's this one here. That's the relay 8. The relay 8 is the black one with no text. Yeah, Nick? And that's what those lines are. This basically means this whole row is all controlled by that relay where these are not. See, so those are all going primary to straight battery. The only way you're going to shut off 127D is by that disconnect on the step well. We're unhooking the battery wire from the post and board. When it says main on the panel, that little green light, that means that those 5 fuses are hot. Okay? If you end up with a current draw, draining your batteries, okay? If you put your amp meter on your cable and you see that it's coming from the board, then you're going to have to clamp each one of the wires that's on this 127D to find out which one's giving you your draw. Okay? Nothing on the board should give you a draw at all. The only way it would is if that relay 8 was stuck closed and the whole board was powered up all the time. Then you're going to have a constant draw on there. Okay? There again, to fix that, tap on it with your screwdriver handle, see if you can knock it loose. I would advise not taking the case off, because if you try to take the cover off of it, chances are you're going to damage it or the board underneath it. Typically, when I've always tried that, that's what happens. It's just awkward to get a screwdriver because of all the other fuses and stuff in the way. And when you finally get it to where you pop it off, you end up bending some of the fuses over or something like that. So it's just not worth trying to do.
A normal draw under 50 milliamps on this overnight?
Typically, what I've seen on all of our chassis is about 0.4. You know, that's pretty common because of the computers on board and stuff like that. So, and I've seen some vehicles go clear up to maybe 0.8. And you know, even at 0.8, you know, it takes probably a couple months for it physically ready.
That's 0.08 or 0.8?
0.8.
That's a pretty big drop.
But that's till the computers and stuff go to sleep. I mean, that's after
Okay,
you
but
turn the
once it
key
goes to
off and you
sleep-
walk away. It's like 15 minutes or
20 minutes,
something
yeah.
like that. Yeah, exactly.
And that's after everything shut down? Or?
Well, that's
No.
when you shut the key off.
Okay, okay.
And then once everything goes to sleep and stuff, yeah, then
Probably
I mean,
around
it should be,
50 to-
yeah, it should be under 0.1 or something like that, or maybe 0.2 at that time. Depending on what you got on. I mean, if you got, if your orbital has a keep alive, you may be drawing more. You know what I mean? Things like that. So anything above that, though, after that period of time, you probably should look for something that's being pinched, because you might have some kind of a battery wire that's going to ground. The 127D is all battery, connects to the main post. You have a primary power and ground post on the board. The relay 8, like I said, is controlled by the 20 purple wire. It's a direct feed off the battery circuit to the relay. So where you see the 50 amp metal fuse on the panel, that's the direct feed to that relay 8. The text on all these have changed for the new version too, so once you get used to those, then we made them a little more common to understand. Our vendor picked what these stampings were on this. We gave them a word that this was a destination sign relay, so they shortened the word to dest or things like that, which made it very difficult for troubleshooting. I like to have the stuff called for what we use it for, not for or shortcut. The top two on here, actually it's the top four, but the top two is the wheelchair and the passenger stop request. Okay? Those are when you pull, you guys got pull cords, I think, right? When you pull that pull cord, that's what you're activating, that's that relay. Okay, if you have just a pull cord, then of course you're just going to use the pass signal. If you have pull cords in the rear that maybe run vertical at wheelchair positions, or you have touch tape,
We have touch tape.
or you have buttons, okay?
Yeah.
So the touch tapes will go to the wheelchair relay. When those are active, they also activate the one that say chime and ADA. Chime is actually the pull cord chime, and ADA is the wheelchair chime. All right? So whenever you activate one of those relays, you're going to activate two. And the only purpose of those other two relays is so not only does the chime go off, because one has a single tone and the other has the dual tone, not only does the chime go off, but it turns the light on, the overhead light that says stop request. Well, that light has to stay on until you cycle the entry door, or if you have a manual override dash or switch in the dash. But without those two relays, that overhead light wouldn't work, because it has to convert basically the signal from power to ground is all it does. Okay. So those four relays are just for the pull cord system. Now you see the diodes on there, D01 and D02, that's coming out on J14 12 blue. That J14 12 blue is that overhead stop request light. Okay. If one of those diodes go bad, when you have the light in the dash that says pass pull cord and wheelchair pull cord, when you pull the pull cord in the vehicle, the light will come on. It says pass pull cord, or pass request is what it says. If the wheelchair request comes on also at the same time, one of those diodes is bad. Okay? Or just the opposite. If you hit the touch tape and both the lights in the dash come on, one of those diodes is bad. That's the only time those diodes should go bad, is to see that. Now the problem is you know, those are 6 amp diodes, but they are not replaceable. So if they go bad, one of two things is going to happen. Either you're going to solder in another diode, or you're going to have to change the board out. Okay. Now the nice thing is there's no load on there. You're talking 1 amp on a 6 amp diode. So there's absolutely no reason why those diodes would ever go bad, at least through the life of the board. Okay. The next one down, the fifth one, is DEST. That's the one we talked about for the driver switch panel. If the back lighting on the switches are not working, that also means your front marker lights are not working. That means there's a problem with this relay or the circuit coming out of this relay. Now this relay is triggered by the OEM marker light wire. If you blow the OEM marker light fuse, none of the lights will work, including anything off that relay. Okay? So if nothing's working, it becomes a little bit more complicated. You've got the OEM fuse, you've got the tie-in point underneath the vehicle with the weather pack connector, you've got the C215 connector inside where that adapter harness runs to, and then you've got this relay. You got the input to it and the output to it. Okay, then you've got the destination sign, you've got the switch panel lights in the dash, you've got the front marker lights. Okay, so there's a lot of things affected by that relay and a lot of things controlling that relay. That's probably the most complex circuit there is because of all the interior and exterior lighting. One below that relay 8 is called entry. That's the one that we sent to you that was functioning, that you're bypassing to not function. Okay, the purpose of that one is just to interlock the entry door with park. That's all. Okay.
Bypass it, go 30 to 87.
To bypass it, what we were doing was we were pulling the 09 pink wire off the board. It comes out of the terminal. We were de-pinning it and pinning it into the battery circuit, just a battery fuse. So that relay is no longer used for anything. You can take that, it's a spare relay. So if you need a relay, that's your relay, the one marked entry.
Well, that, with it the other way, you had to put it in park
To open the door, right. Right. Okay. The bottom one below that says jar. Okay, that circuit right there basically is self-latching Triggers off of 24 pink. Triggered off 23 yellow. That's your window ajar. That's why I don't like those words. A jar can be anything. Big cup holder jar. The window ajar, I don't know if you have those on the vehicle or not, but anytime your window's open, you get a buzzer.
Rear window.
Rear window? Okay. So you are using that one. The only one you're not using on here is entry. Okay? And a lot of the wires you'll see jumping on here, there's a lot of splices on the board, but that's how we got rid of that big spaghetti mess of wiring behind it, is we run a lot of wires in and a lot of wires out. They don't do anything. They just go in and out. If you have a problem with a trace on the board, where say a trace melts between two circuits, okay, if looking at that print you see that there's a jump but it doesn't go anywhere else on the board, well really all you got to do is take those wires and tie them together on another point on the board, you know, where the other one is, and you don't need to replace the board. You know, keep your downtime, you know, at a minimum. And maybe just temporary, even, you know, while you're waiting on a new board or something like that.
Do we have an emergency door in these buses in the rear?
I don't believe so.
What was the question?
Rear door? You got a rear door in?
No.
No.
It is-
So the driver complained that there was a rear door and the light was coming on the front.
Well, the rear window.
Or window. That's
They
what
can
I
next
mean.
rattle.
Window ajar.
Oh, okay.
Yeah.
So that's that relation.
Yeah.
Yes.
Yeah, now if your latches on the window become loose, or the magnetic switches in the window come loose, you will have
Okay.
buzzer light issues, random issues.
We're gonna see that in the bus?
Hope not.
No.
Oh,
Well,
I mean-
you know, when they call me, you know, these lights.
Yeah, well,
you know what-
I can show you where they are.
Okay.
But yeah, basically what we do is we take a magnetic reed switch, we attach the magnet to the window, and we put the switch part, the wiring, and the jam itself, the frame, and then of course they work within 3/4 of an inch. So. Okay. This section right up here, from the C106 and 111, is all the rear cap. Okay, that's the back wall. Right up here you'll see C160, it says seal plug. That's the toe plug. If vehicles are sent from our facility by a driver that's towing his own car, used to be, we kind of talked about this last time, they would pop out the tail lights, stick bobby pins through the wiring, tow the vehicle, and then put it back together. Number one, you broke the seal on the lights. Number two, you put a hole in the wire, and all they do is corrode because the seal of the light's going to let water through it, and the hole from the bobby pin is going to corrode the wire. Next thing you know, within 3 months, you're not going to have any functioning lights. Okay? If you ever take the lights out, they need to be resealed from the inside. There's those two panels that run up the sides. Basically, when you're looking at the back of the vehicle, you've got the evaporator. You've got these two panels that run down the corners. They have screws, like 4 of them on the outside. Has a H-lock trim right in the middle. Pop this H-lock off, pull that panel out. Sikaflex, or we can't use silicone at our facility because OSHA. We have to use Sikaflex. Sikaflex is just a brand of a silicone. So, I mean, use whatever you use. I mean, we would use silicone if we could because it's better as a holding agent than the Sikaflex is. Sikaflex likes to rip. But we'll pull that off, pull that out. You got the tail light in there, make sure it's sealed. If you ever replace the tail lights, make sure you seal them back. Okay, you want to seal around the rubber gasket and around the light where it goes to the gasket, because the gasket is not a seal around the light. The gasket is just for vibration protection from the light being mounted into the surface. Okay, so that's very important. The toe plug was put in so that drivers would not do that. Okay, they are supposed to buy an adapter that we make that plugs the OEM chassis to that toe plug, and then they can pull their vehicles behind it. But I think California is a no-toe state. tow any vehicle into California, if I remember right. It depends on what's on the specs that they were built. You guys build off the state contract?
Yes.
Okay, then you're on no tow, so you should have no vehicles towed. You should not have to worry about broken seals or wiretapped wires. But in any case, if you go looking in there for whatever reason, inspect those lights, make sure they're sealed, because if they do break, you're going to end up with some corrosion behind there. Okay. C161 is actually the connector that is on the inside, and it's used for a Ford or a little Chevy chassis. Okay, that's where we pick up all the exterior wires. That's a spare plug if you ever need it for anything, for picking up any of those signals back there. If you put on any kind of a new technology backup video system or whatever you want to do, you always have those circuits that keep you from tying into other stuff. You just use the mating connector internals, plug right into it, use whatever you want. Same goes with the turn signals. You have 09 brown as marker, 18 white is backup, 18 yellow is turn, 18 red is turn, and 9 blue is brake. Okay, so you have all those wires there. You have the reverse alarm, which right now I have on this print as ring terminals, which is what you have. But we made a change to a different backup alarm company, and they now make the connectors plug and play to our vehicle, so they should have weather packs on there, not ring terminals. Okay, we've really been pushing our vendors to go plug and play with us to make it more simple, so we're not relying on our production guys hand crimping terminals to try to make it plug and play. We want our vendors to send the parts in, and then we can just plug them in as we install it. It's very difficult when you deal with as many vendors as what we have. Unless you specify different, you guys, I think the state contract is Dialite.
I don't know. I just ring a bell, but...
Because we use Grody as standard. We'll look when we get out there. It should be stamped on the lens what the manufacturer is. If they're Grody, they come in pre-terminated from Grody to us. And when you buy parts, we can give you the part numbers that allow you to buy them with the connectors already on. So you just, when you replace lights, you just plug them in. The LED, do you know?
Yeah.
Okay. Yeah, but I bet you they're either Dialite or Grody.
I want to say Grody, but I'm not sure.
Fuel door switch is shown on here. That's basically O3 gray, and it's going to ground. There again, we use a magnetic reed switch for the fuel door switch. If you have problems with your engine periodically shutting down, that is the first place I would look, because either that switch has come loose or maybe the wiring is corroded to it. That is not a sealed connector that's in there, because you guys, I think, have the metal. Yeah, you have the steel fuel fill. So we can't get the connectors through that steel plate, so we have to use regular connectors on the back side of it. So there's always that potential that they could corrode. I mean, they're not exposed to the outside, but you still could end up water getting through the hole where the wires come through. You have touch tape for your right hand and your left hand. You have touch tape somewhere on here, for right here, your pass request pull cords, left and right. You also have your grounds, which is shown here for your driver's rear seat track. That's the one we showed you in the book that is called the redundant ground. You have all your regular lighting, all shown through there. All the ones that are not marked, like you have this C149 and it has nothing next to it, that means you don't have that component. But that is a spare if you needed a new connection for 09 blue, which is the brake wire, or just a ground. You can plug that in right there and make it plug and play. You have the speaker system, which all goes to your orbital system. You have your rear heater. The way we do heaters is we do front and rear heaters. We call them heater 1 and heater 2. There's no consistency to them. It used to be, whenever we put in one heater, you always got heater 1. The problem is, on that long of a bus, you could have 80 foot of wire going to it. Okay? And it running at 12 amps, that becomes kind of dangerous. Okay? You'd have to upgrade your wiring to do that. So what we did is we created a new process, and that thing is set up so that you have front and rear, heater 1 and heater 2. So depending on your vehicle, we'll draw a crude picture of a bus here. You got your wheel well, you got your entry door, you got your driver's seat. Okay? Now what you have is heater 1, and you have heater 2. If the heater is anywhere forward of the wheel wells, you're always going to get the heater 2 drop. So in troubleshooting your wire, that's what you'll look for. If you have anything behind the rear wells, you'll always end up with heater 1. So if you're looking to troubleshoot whatever heater, if you got 4 heaters in there and one of them giving you a problem, that's how you find out where the wiring is. Okay? That keeps us from using heater 1 and running the wires from here all the way back and all the way back up front. Then we just split them. And that includes if that heater is setting over here, it's still going to go here. Okay? So that's your rear heater 1, and right here is your other heater. And you see that they all are separate circuits. The 04s are going to be the heater 2, and the 07s are going to be the heater 1s. And they will match your switches that way in the dash. You have the 48-inch fluorescent lights. You have a relay and the dome light circuit on the driver's side. Okay, and that relay is
well, there's a bell relay over there right by the rear heater too. There's a dome relay over here by the rear heater too.
well, that's the switch. Yeah, that's the switch. I don't know if we put that relay on here because it's only put in with 48-inch lights.
We're gonna see in the bus what is that relay?
It will be behind the panel. The new EP3 actually has it built onto the board. All of the relays are on the board. The heater relays, the dome lights, the reading lights. On your vehicles, when you don't show this relay, then what they've done is something a little bit different. Instead of using the dome light drops, they use the reading light drops. So you end up with a separate fuse on each side. Okay? That would be the only difference between the two. Now on yours too, you might have a relay back there that, actually I think we might have removed those, but we used to put a relay in for a clean signal for 09 orange, which you wouldn't have used anyway, and none of the circuits you would have used. But when we had people that had flashing step lights, and you would open the door up, it would cause the exterior lights to pulse, and the interior dome lights to pulse, so we put that relay in there to clean up that signal. But since they're standard harnesses, you know what I mean, it's hard to guarantee whether you have that or not, because if they tried using up old stock, you may end up with a harness with a relay in there, but it doesn't matter because it's just a spare relay. If it went bad, it would never affect you in any reason. Okay? So you should never have to troubleshoot it. And if you see it back there, you don't have to do anything with it. Okay? Radio drop. If you call out on the work order that you want your speaker wires dropped in the overhead storage, I'm not sure how that was set up. But if they want them dropped out in the overhead storage, then they would run the speaker wires instead of down here. This is actually the radio hole in the dash. They would run this up above. Okay, so it's all just by location based on the work order. The 28R12W 08A black right here, C134 is actually the chime. That's the dual tone, the big speaker chime that's mounted behind the fiberglass piece. You can surface mount those if you prefer that. We don't, because they're loud enough behind it, and it's just easier not to have one more thing to mount out in the open. But if you have drivers complain that they can't hear it or whatever reason, then you can always drill a hole and mount those surface mount. They're capable of doing that. This is the overhead stop request sign, the C195. That thing comes on anytime either the wheelchair or the pull cord, that's what's controlled by these diodes. Anytime the pull cord or touch tape is activated, and it will not reset unless you cycle the entry cord. The Echo Vision shows how it's wired in, the sensors are set. The Chevy 5500 engine kill, is what we have determined that is. The tie-in point for the fuel pump relay. All this section right here on the bottom right corner from C100A and 100B, this whole section is all the switch wiring behind the switches. Okay? And these connectors should be color-coded also. Same goes with the C100C. It actually belongs with A and B. You have the destination sign wiring, which has the power, light, ignition, and ground. That's the pre-prep that's always there in every vehicle. That's what you're using to power your equipment up there. You have the driver's fan wiring. All in this section here, you're going to have all the entry door items. And what's one of the things we want to touch on here is the entry door has its own module controller for it. It also has the switch in the dash. Now by the switch wiring you see, basically what you had before was you had plus 12 volts coming into the entry relay. Then you had it turn around and going out to switch panel, or the driver's switch panel, switch in the dash, and then you had 9 yellow, 9 white that turned around and went to this entry door module, and then it had 12 volts and ground. Okay, and this is located at the entry door. Alright. Now through this process, this is the part we've changed right here. We basically cut the circuit and we run it to 12 volt battery. So it still runs to the switch in the dash. Those two wires for open and close still go to the module above the entry door. Now that module has LEDs on it that tells you if it has a problem, what to troubleshoot on it. I think I sent a deal up to Russell from A&M, a print of their troubleshooting guide for the module itself. I can't remember. If that's something you guys find that you need and you don't have it or whatever, give me a yell or have Russell give me a yell or something, I'll send it. But it gives you, actually I think you can find it on the website too. ANMsystems.com I believe is their address. But if you search for A&M entry doors, like Google it, you'll find their website. It's pretty easy. But they have a troubleshooting guide for that module. Basically, it's got relays on it and it's potted. It's about 4 inches square. You can physically see the tops of the relays, but you can't see anything else but the relays and the LEDs because it is potted. And it has 4 wires coming out of it, 2 small gauge wires and 2 heavy gauge wires. And by heavy, I mean they're only like 12 gauge, and the smaller ones are more like 16 gauge. And then whenever you activate the switch, you're basically operating this, and when you operate this makes the actual door work. If you check the wiring, 09 white and 09 yellow above the door, say the door's not working, put your test light up there, or your meter, run the switch and see if it works. If it works, this module's bad. If it does not work, then of course you'll have to go to the back of the switch and try the same thing. If it works here and not here, of course you got a spot in the wiring where it's been cut on its way to it.
How many lights are in the module?
What's that?
How many lights?
There's 2. Yeah. I believe, I'm just guessing here, but I believe they're yellow and green. You also have exterior entry door key switch option, which basically shortcuts all the other stuff and then direct feeds to the module itself. You have the step light switch above the door, or if you're opening the door and your step lights do not come on, chances are it's that switch. If your dome lights do come on, but your step light doesn't, then it's going to be in your step lights. Because the same wire controls the overhead lighting when the door is open as it does the step light, both interior and exterior. Okay? This is where we got right here, interior step light, light above the fare box. All work with the entry door, or headlights. You have the tie-in for the Chevy 10-way bus connector. That's the one we talked about, the C215 for the OEM wiring. We also have the C193, which is only the 20 purple is used. The 18 red and the 18 yellow were used on Ford units only. And then you have the Chevy 5500 tie-in for 07K and 08 orange, which is a park signal. And that park signal only works after 20 seconds of the vehicle being started. Okay, you will not receive a park signal before then. You want to change that tape? We created these prints, and with the idea we were going to create a website that had all the drawings. And you could go type in your vehicle Eldorado VIN number, and it would tell you all the prints you needed for it.
Send these down, have them copied, and laminated, just like this.
So,
Pass them
all in all, in the end, it'll be a lot better. They're just still writing the website.
Yeah.
Once that's done, it will be a lot more user-friendly. It's just a local company, Web Creative. These same people who build our standard website, but they contracted out to another company.
Yeah, this area is huge.
Yeah. So I don't know who they're having doing it, on the backside, but it's going to be a different address. Like if you go to enconline.com, that's our website for both us and the California plant in Riverside. And then, whether you click bus or van, it takes you to whichever plant. Well, I think our site is actually going to be like support.enconline.com, and it would have nothing but contacts, prints, the whole 9 yards. Yeah, I'm sure there'll be places where you can submit, questions direct in, and it'll pull up, whatever prints or relationship to that type of deal. You good to go? All right. This section right over here on the far left corner is the front marker light circuits. Go up from that, basically you have this is the power distribution. You have your body disconnect, you have your batteries, your lifts, alternators. You have your stator wire, your charging monitor, and of course it gets up into your Thermo King. And if you see, Thermo King has a manual 90 amp breaker there. That 90 amp breaker it could be in two places, and it kind of varies on vehicles. Sometimes it's behind the electrical center, the one above the driver. Other times, if you have a front storage, it's actually physically mounted to the shelf where all your equipment's going to be. So it kind of depends on when production was doing it, what was the easiest at the time to do. The correct spot is in that general area. Now, if they tried to mount it up front there without a sign, door opening, it would be almost impossible, for them to do and for you to troubleshoot if it came to that. But I have seen cases where they mounted those breakers under the shelf. Okay? So just to make you aware, and I don't mean all the way under it, I mean where they slide it up to the edge, underneath the edge of it, they screw it down, and you look in there and you can't see it. But if you kind of climb up in there and look down, you'll see it right there at the edge of it. So, and it's probably a good idea to know where that is because it is manual. So if it does trip, you're going to have to reset it.
Yeah, we need to know what that is.
So, and the best thing to do is to take the power wire off the electrical center and just follow it because it's only, like 16 inches to where the breaker's going to be. So, and it's the only breaker that should be up there. And it's one of those big lift breakers, the big black ones that's mounted like in the battery tray for your lift. It's the same thing, only it's a 90 amp. Yep. You have your ground plane, you have your Roscoe mirrors, and then of course you have your orbital system. This orbital system schematic is generic that they supply to us. I have no idea if that's accurate for what you use it for and your features that you have. We put that on there just to kind of give you an idea of what they expect in their system, and this should be correct, but it just may not be completely 100% complete for what you do. Because orbitals, just like any of the other systems, they sell them by option. So how sophisticated you want to get with the options is how sophisticated your wiring is going to be in the vehicle. So whoever your guys that are dedicated for that probably know exactly what you do, and that probably doesn't even matter. But I got any questions?
Yeah, the disconnects,
Yes.
the guys said those weren't holding up too well.
Yeah, I'm not sure why, because they're rated at like 200 amps. Now I do know that when we get back, I'm going to review the wiring on that, because I know as we've upgraded ACs and things like that, we've never really upgraded the wiring. We've done load tests on it. We haven't seen any issues. different kind of switch that we were looking at using. Typically, when you have cables burning on the switch itself, like discoloration, usually you would assume that the connectors would be loose, like the ring terminals would be coming loose or something like that. But that's not necessarily the case all the time. So I will look at it when I get back and make sure that load-wise the cable is adequate for what we're running through it. So
But doesn't that just come off the starter? I thought somebody said it's right to the starter to that switch.
it goes direct from the it should go direct from the battery. Should go. Now we do have other cables that probably go from the starter, like if you get an upgrade alternator, stuff like that. But the battery cable, but those cables should go from the battery because on a Chevy they have standard locations under the step, driver step well, so it's really easy to get to those points. So it's a guarantee that that's where they should come from. Our guys are going to do the shortest thing easiest because of the short time frame they have with the vehicle. So
Are the relays easy to remove?
yes, you don't have to worry so much like with the RC Tronics. You couldn't rock the relays back and forth. You don't have to worry about that so much with this thing. But I'd still kind of be careful and only rock it when you would need to get the relay out. But no relay is going to pull straight out. I mean, it's almost impossible to do that without using some kind of a screwdriver or something underneath to pry it. So I would rather you kind of rock it a little bit than I would trying to stick tools up in there. Because that's going to be its one delicate point. It's going to be sharp objects cutting those copper traces. Now there is cases where you may end up where you want something to work different, and we can work with you on those cases, and we've for other customers we've cut traces on the board to cause things to function differently. So far I think you guys have been running pretty good. I mean, I haven't heard anything as far as needing to change anything so far. You guys have had these for a while, right? Couple months anyway.
This series, I don't know. They start trickling in. Yeah, I guess so. Huh? Slowly.
So yeah, I was definitely.
I mean,
6 weeks, couple of months.
6 weeks. Yeah.
Because I think the first one was like 1st of February or somewhere.
Yeah.
Right in there or something like that. Have you experienced any less problems or more problems on the RC Tronic?
Different board though.
Yeah.
This is less problems. I mean, so far, these RC Tronics boards are, they're just not the greatest. I mean, we had some failures with the boards on those that were warranted, and we changed a couple. I believe even out here, it was quicker. But I think a simplified board here is the answer for troubleshooting and stuff. So.
Yeah, I'm well experienced in changing RC Tronic boards.
Boy.
We started using those in the plant. I was the one who changed them.
Oh. Yeah, that's a lot
It
of
took
work.
too long for production to do it. I mean, they couldn't stop and change a board.
Tremendous amount of labor there. Yeah. Easy to mix things up.
Well, at least his newer board comes right out too. The other one doesn't know wood drop and stuff. You gotta play right.
Yeah. When you take the screws, if you try to take the board out of the box, you can't because all the wires are there.
Yeah.
If you try to take the box out of the bus, then the boards fall.
Yeah.
It was quite a mess.
Yeah.
Chinese puzzle.
We were pretty excited to get away from that. It was one of those products that was good in theory. The vendor had shown us the product, and it was a lot different than what we used. It was a step forward for us, but in the end, it ended up being a few steps backwards. Since then, I hope we've kind of recovered. That's the purpose of all this, was to get back where we wanted to be to begin with, and ended up in the mess we had. And there was really nothing wrong with the boards. They were just not really designed. I mean, our competitors use them, and they don't have the failures. Don't ask me how or why. But they don't put as many buses out on the street, that we do either. So when we see problems, we see problems.
Usually we're pulling for connections behind the board.
Yes. Yeah. Or the adapter.
It'd be nice to convert them all to this, but what a job, man.
Yeah, that would be impossible.
Oh, man.
Well, actually, it probably wouldn't be as bad as you think it would. You need a different adapter harness.
Yeah.
But the RC Tronics wiring, now if you tried to take an old bus, like an EP1 for a Ford and tried to do that,
No,
it
no.
would be impossible.
No.
But for these buses, they're already point-to-point wiring for signals, ground inputs, power
It'd
outputs.
be nice to come up with an upgrade kit, you know?
Listen to buses.
I guarantee you this, the vendor who makes our system for it, harness for it, if you wanted something like that, he would make it for you.
I'm sure. Nice.
What is the starter kill relay?
That is the engine kill relay. That's for the fuel door shutdown. That's why earlier I kept saying that was a starter kill, because it says starter, or starter disable, I'm sorry. I kept saying starter disable, but it was actually the engine kill.
Where's that relay at?
It is going to be at the fuel pump source relay.
The fuel pump of these buses is in the tank?
It's in,
Fuel tank.
is it it's inside?
Yeah, it drops in there. It's a standard GM fuel pump.
Okay. We got so many of them. Some of them are on the frame rail, some of them are
Yeah,
inside, some of them are on top,
Well, we have an access door cut on our buses too.
floor.
Yeah, that's nice. Well, was the access door something you guys put in, or did we ask for that? Did we spec that?
The what?
The access, the floor hole?
You have to ask for it.
Yeah.
That's not standard.
That's an old thing that we started years ago with our flex buses to get on, to get to the,
You'd be surprised how common that is.
oh yeah, is
A
it?
lot of people have that
Uh-huh.
thing.
Huh. I like it. Yeah.
And they complain when
After you
they're in the
drop
wrong
a
spot.
couple of 100-gallon tanks.
We got some where guy opens it up, so hey, I took my plate off and I see nothing but the ground. And it's supposed to be the fuel
Yeah.
sender.
I haven't looked at that yet, but I wonder will the fuel pump assembly come out of that door? It won't. Oh, so it'd have to go up the side anyway.
That is just to be able to access it.
Oh,
It's
you
not-
can't lift it up through there. Oh.
You can probably make it bigger, put a
Bummer.
bigger plate on there, but that plate
Yeah.
that's in there is probably only that big, and you know that down center.
Oh, yeah, it's big, yeah, I was wondering.
Assemble it in place and pop your arm off.
Yeah, you can at least,
Now, see, we used to only do those for people who did auxiliary items, like they did fuel fire heaters or things like that, and see, we would tie those in to the auxiliary ports on those.
Mhm.
But we put those doors in there so people could get to those auxiliary points, and that was all they were for. I mean, they weren't really for actually physically doing anything with the fuel tank, you know.
yeah.
But people like them so they can troubleshoot, to at least determine if they've got to drop that or not. You know, it's always a pain to drop it. It's like you didn't need to, you know.
Oh, yeah, find a way to get it out of that hole anyways.
Yeah, you can definitely cut it bigger. You got a bigger plate to go over it. There's no reason why you can't. I mean, we have our floor steel set up underneath where that wood falls in between them. So you'd have to make sure when you're cutting it out that you're cutting away from it.
Maybe you could suggest putting a bigger door in there to begin with. I mean, to your production people.
Well, I don't think it works that way.
Oh,
I
yeah?
think, and that's the mechanical guys, you know what I mean, that do all that. But I think part of that has to do with integrity, walking through the inside of the bus and stuff like that.
Okay.
Because the more you cut out, the worse it's going to be.
Yeah.
If you're putting
Cracks
plate
and
in,
stuff. Yeah. True.
Well, other than that, I guess, you guys want to take a 10-minute break and then